to part 2 of our chat app using WebSocket series. In the first part, we explored the development of the backend API using Fast API. We reviewed how to implement a WebSocket endpoint and tested the communication using Postman. If you missed it, be sure to check out that video to get caught up. To recap, in part 1, we set up the Fast API backend. We created a WebSocket endpoint to handle real-time communication and tested it with Postman to ensure our server could send and receive messages correctly. Now, we're ready to move on to the next step. In this part, we will develop an Angular front-end application that will communicate with our Fast API backend. We'll implement WebSocket communication in Angular to send and receive personalized messages as well as broadcast messages to all connected clients. By the end of this tutorial, you'll have a fully functional chat application with both backend and front-end components working seamlessly together. First, we'll start by setting up our Angular project. We'll create a new Angular application and install the necessary dependencies. We'll also set up Angular material to enhance the user interface of our chat application. Next, we'll implement a WebSocket service in Angular. This service will handle the WebSocket connection, sending messages to the server and receiving messages from it. This service will be the backbone of our real-time communication in the front end. After that, we'll create a chat component in Angular. This component will include the user interface for our chat application, where users can type and send messages. We'll also display the received messages in real time. Finally, we'll connect the Angular frontend to our Fast API backend. We'll integrate the WebSocket service with the chat component, enabling real-time communication between the front-end and back-end. We'll test the application to ensure messages are sent and received correctly. To follow along with this tutorial, you'll need a basic understanding of Angular and TypeScript, as well as the code we developed in Part 1 for the Fast API backend. If you're ready, let's dive into building the Angular frontend for our chat application. Don't forget to like, share, and subscribe to our channel for more tutorials. Let's get started with part 2 of our chat app using WebSocket series. Before we dive into developing the Angular frontend for our chat application, we need to ensure that Node.js and Angular CLI are installed on your machine. In this segment, we'll show you how to check the versions of Node.js and Angular CLI, and if they're not installed, we'll guide you through the installation process. Let's get started. First, let's check if Node.js is installed and what version you have. Open your terminal and type the command node-v. If Node.js is installed, you should see the version number printed in the terminal. For this tutorial, we're using Node.js version 20.10.0. If you don't see a version number or if your version is different, you'll need to install or update Node.js. To install Node.js, visit the official Node.js website at nodejs.org. Download the LTS, that is long-term support version for your operating system, and follow the installation instructions. The LTS version ensures stability and long-term support, which is ideal for development. Once the installation is complete, verify the installation by running the node-v command again in your terminal. You should now see the version number 20.10.0 or higher. Next, let's check if Angular CLI is installed and what version you have. In your terminal, type the command ng version. If Angular CLI is installed, you'll see the version number along with other details. For this tutorial, we're using Angular CLI version 17.3.0. If you don't see a version number, or if your version is different, you'll need to install or update Angular CLI. To install Angular CLI, use the Node Package Manager (npm) that comes with Node.js. In your terminal, run the following command: npm install -g at angular/cli at 17.3.0. This command installs Angular CLI globally on your system, making it available for any project. Once the installation is complete, verify it by running the ng version command again in your terminal. You should now see the version number 17.3.0. Next, open your terminal and create a new Angular project by running the command ng new Angular chat. cd Angular-chat. npm install at Angular/material and at Angular/cdk. Type ng-serve to start the application. Application is now running at localhost port 4200. Open browser and navigate to the URL localhost port 4200. It will show the default page. Type Ctrl+C to stop the running application. Once you're in your project directory, you can open the project in Visual Studio Code by typing the command code. The code command opens Visual Studio Code, and the dot indicates that it should open the current directory. After running the command, Visual Studio Code will launch and load your Angular project. You'll see the project structure in the Explorer pane on the left side of the window. If the code command is not recognized, it means the VS Code command line interface is not installed. To install it, open Visual Studio Code, press Ctrl-Shift-P to open the command palette, and type shell command. Shell command: install code command in path. Select this option, and the command should now work in your terminal. We'll be exploring the basic code structure of a newly created Angular project. Whether you're a beginner or need a refresher, this guide will help you understand the core components and how they fit together. When you create a new Angular project using the Angular CLI, it generates a set of files and folders that follow a specific structure. Let's explore this structure step by step. The src folder is the heart of your Angular application. It contains all the source code for your project. Inside src, you'll find several key components. The app folder contains the main application module and components. The main.ts file is the main entry point for your application. It bootstraps the root module. The index.html is the main HTML file that loads your Angular application. The style.css file contains global styles for your application. Inside the app folder, you'll find the core components of your Angular application. The app.component.ts is the root component of your application. It defines the main structure and layout of your app. The app.component.html file contains the HTML template for the root component. The app.component.css file contains styles specific to the root component. Components are the building blocks of an Angular application. They control a part of the screen called a view. Components are defined using three files: a TypeScript file, .ts, an HTML file, .html, and a CSS file, .css. Apart from the source code, there are several important configuration files in the root of your Angular project. Angular.json file contains configuration settings for the Angular CLI, including build and test configurations. Package.json file contains metadata about the project, including dependencies and scripts. tsconfig.json file contains TypeScript compiler configuration options. In summary, a newly created Angular project follows a well-defined structure that helps you organize your code and manage dependencies effectively. By understanding the purpose of each folder and file, you'll be better equipped to navigate and develop your Angular applications. Now that our development environment is set up, let's move on to creating our Angular project and setting up the WebSocket service. Stay tuned and let's continue our journey in building the chat application. Generate a WebSocket service to handle WebSocket connections. Implement the WebSocket service in Angular. First, we import the necessary modules. Angular Core provides core Angular functionalities. RxJS stands for Reactive Extensions for JavaScript, a library for composing asynchronous and event-based programs. We specifically import Observable and Observer to handle our WebSocket events. Next, we define our WebSocket service using the injectable decorator. The injectable decorator marks this class as a service that can be injected into other components. The provided in root syntax ensures that this service is a singleton available throughout the application. Within our service class, we declare a private variable for our WebSocket connection. This socket variable will hold the WebSocket connection instance. Now, let's look at the connect method. The connect method accepts a URL as a parameter and establishes a WebSocket connection to that URL. We create a new observable that handles the WebSocket events. On message. When a message is received from the server, observer.next pushes the message to the observers. On error, if there's an error with the WebSocket connection, observer.error notifies the observers. On close, when the WebSocket connection is closed, observer.complete signals the completion to the observers. The return statement within the observable function ensures that the WebSocket connection is properly closed when the observable is unsubscribed. The send method allows us to send messages through the WebSocket connection. This method simply takes a string message and uses the WebSocket's send method to transmit it to the server. If you scroll up, you will notice that underline below socket variable indicates that there is some problem with variable declaration. Add exclamation mark next to the variable name to get rid of the error. This non-null assertion operator in TypeScript is a postfix expression operator used to tell the TypeScript compiler that a variable or expression is not null or undefined. It effectively overrides TypeScript's type checking for that particular variable or expression, which can be useful in certain situations where the developer knows more about the context than the compiler. To recap, we've created a WebSocket service in Angular that connects to a WebSocket server using the connect method, returning an observable to handle messages, errors, and connection closures. Sends messages through the WebSocket connection using the send method. This service leverages Angular's dependency injection and RxJS to provide a clean and reactive way to interact with WebSocket servers. Next, we need to generate a new Angular component for our chat feature. Open your terminal and navigate to your Angular project directory. Run the command ng generate component chat. When you run the command ng generate component chat in your Angular project, several things happen automatically to streamline the creation of a new component. First, the Angular CLI generates a new folder named Chat within your project's specified module or directory. Inside this folder, for essential files are created. Chat.component.typescript file contains the logic for your new chat component. It includes the class definition and necessary imports, providing the structure for your component's behavior. Chat.component.html file is the template for your chat component. It defines the layout and structure of your component's user interface. Chat.component.stylesheet file contains the styles specific to your chat component. You can define the look and feel of your component here, ensuring it integrates seamlessly with your overall design. In the chat.component.typescript file, the selector for this component is specified as AppChat. We will add this component to the app component, which is the root component of our project. Before doing that, let's remove the boilerplate code that was generated when the project was created. After cleaning up, we will add the AppChat tag to integrate the new component. Notice a red underline beneath the AppChat tag. This means that our app component doesn't recognize the chat component yet. To fix this, we need to inform our application about the new component. This involves importing chat component into the app component. Let's go to the app.component.typescript file. Next, we need to add chat component to the imports array in the app component. This step is crucial to make sure our application knows about the chat component. Then we need to import the chat component. With all these changes done so far, let's run the application and see the effect of the code changes we made. Open your terminal or command prompt and navigate to your Angular project directory if you haven't already. To start the development server, type the command ng-serve. Now, hit Enter. The Angular CLI will compile your application and start a development server. Once the server is up and running, open your web browser and navigate to localhost port 4200. But did you know you can also open it directly within Visual Studio Code? Let me show you how. Press Ctrl plus Shift plus P to open the command palette. Type Simple Browser, Show, and select it. A new tab will open within VS Code. In the URL bar, type localhost port 4200 and press Enter. Here, you'll see your application running with the new chat component integrated seamlessly. When you run your Angular application using the ng-serve command, it starts in watch mode. This means any changes you make to your code will automatically be detected and the application will reload in the browser. Let's see this in action. Here, we have our chat component open in Visual Studio Code. I'll make a simple change to the component's HTML. After making this change, I'll save the file. Notice how the Angular development server automatically detects the change and recompiles the application. You'll see that the change is reflected immediately without needing to refresh the page manually. Now, let's update our component definition. Open the chat.component.typescript file. In the class definition, we will implement the onInit interface, which requires us to define the ng-onInit method. This method is part of Angular's lifecycle hooks and runs after Angular initializes the component's databound properties. Within the class, we define two properties, messages and new message. Messages will hold the list of chat messages, and new message will store the current message being typed by the user. We will return to this component code shortly. For now, let's add some UI elements to chat.component.html. Add a div tag with class name as chatContainer. In the chat.component.css file, create a CSS class called chatContainer. Inside chatContainer, add another div with the CSS class messages. In the chat.component.css file, create a CSS class called messages. Inside messages container, add another div tag to show list of messages. This Angular code is used to dynamically create a list of div elements, each containing a message. ng4 let message of messages is an Angular structural directive that iterates over the messages array. For each element in the messages array, it creates a new div element. LetMessage declares a template input variable named message that holds the current item from the messages array during each iteration. This is Angular's interpolation syntax. It inserts the value of the message variable into the div element, so each div will display the content of one message from the messages array. In summary, this code loops through the messages array and generates a div for each message, displaying the message's content inside the div. In Angular, if you encounter an issue where ng4 is not being recognized, it's likely because the common module has not been imported where the component using ng4 is declared. The common module is essential because it provides common directives like ngIf and ng4. Save all changes so that Angular recompiles all changes. Inside chat container, add another div with the CSS class input container. Also add a new CSS class. Next, add an input element and bind it to a variable using the ng model directive, which enables two-way data binding. Here's an explanation of how to do this with the new message variable. You need to import the forms module for the chat component to recognize ng model. Input element is a standard HTML input element where users can type their messages. ng model directive is provided by the forms module and is used to bind the value of the input element to a component variable. This two-way binding syntax is shorthand for two-way data binding in Angular. It combines both property binding, which sets the value of the input from the component, and event binding, which updates the component variable when the input value changes. Next, add a button with caption Send. Before we proceed, let's adjust the CSS to ensure the entire UI is visible without needing to scroll up and down. Next, we will connect our Angular front end to the WebSocket backend. In part 1 of this video series, we learned how to test the Fast API WebSocket backend using Postman. In this session, before adding the capability for the chat component to connect to the WebSocket, we will use another method to ensure the backend service is up and running. This time, we'll use an extension called WebSocket Client within Visual Studio. Next, we'll focus on initializing WebSocket connections and handling incoming messages. Let's get started. First, we have two variable declarations, messages and new message. Messages is an array of strings that will store all the chat messages we receive. Initially, it's an empty array. New message is a string that will hold the current message being typed by the user before it gets sent. New message is a string that will hold the current message being typed by the user before it gets sent. This variable will be bound to the input field in our HTML template. Next, we'll define the constructor for our component and inject the WebSocket service. This service will handle the WebSocket connection for us. By injecting the WebSocket service, we can use it to connect to our WebSocket server and manage communication. The private keyword ensures that the service is only accessible within this component. Now, we'll use the ng-on-init lifecycle hook to establish the WebSocket connection as soon as the component initializes. In the ng-on-init method, we call the connect method of the WebSocket service with the URL of our WebSocket server. This method returns an observable that we subscribe to for handling incoming messages, errors, and connection completion. The first property is next, which handles incoming messages from the WebSocket server. When a new message is received, the next function is called with the message as the argument. We push this message to the messages array, allowing it to be displayed in the chat. Next, we handle any errors that occur during the WebSocket connection. If an error occurs, the error function is called with the error object. We log the error to the console for debugging purposes. Finally, we handle the completion of the WebSocket connection. When the WebSocket connection is closed, the complete function is called. We log a message to the console indicating that the connection has been closed. To test our WebSocket implementation, we'll use a WebSocket client tool. With our WebSocket communication set up, we're ready to implement the method for sending messages from the input field to the WebSocket server. Stay tuned as we continue building our chat application. First, let's add the send message method to our chat component class. This method uses the WebSocket service to send the current value of the message property, which holds the text typed by the user. After sending the message, it resets the message property to an empty string, effectively clearing the input field. Now that we've added the send message method, let's ensure it's properly integrated with our template. In chat.component.html, add a click event to the button and bind it to send message method. In this series, we developed an Angular front end for our chat application. We started by setting up the Angular project and configuring the necessary modules. We then created the chat component, implemented WebSocket communication with our backend, and added functionality to send and receive messages. Finally, we tested our application using WebSocket client and browser to ensure everything works seamlessly. With these steps, We now have a fully functional real-time chat application using Angular and WebSockets. In part 3 of the series, we will cover how to send personalized messages. Stay tuned as we continue to enhance our chat application with more advanced features. Thanks for following along and happy coding.